Hello everyone, my name is Barbara and I will present you my work that is recognition of maximal speed limit traffic signs for use in advanced ADAS algorithms. I don't have power or PowerPoint. Oh, there is. So this is the content and we can start. ADAS, that is Advanced Driver Assistance Systems, are systems that helps drivers in their driving, and in future I'm sure that they will take over control and drivers will be just passengers. One application for that kind of system is speed limit recognition system, and our work is implemented on a real ADAS platform. Detection is done with model from Texas Instrument, and recognition is done by Convolutional Neural Network. So this is the hardware, this is the board on which our solution is implemented. It consists of 3 systems on chips and then camera inputs. The software which comes with this board is from Texas Instruments. It's Vision SDK, and whole code is in C programming language. Something about the concept of solution. First step was image pre-processing. The input video frame in this whole solution was U420SP video frame with a resolution of 1280 by 720 pixels. And the first step was low pass filtering, and that was used to reduce high frequency noise. And next part was image pyramid algorithm to detect target traffic signs of any size with an image. Second step was detection of traffic signs of interest, and the last step was recognition. Here we can see the flow chart, and different colors represents different processes on which operations were performed. Something about detection. So I already said that the board comes with software, and that software has ready-made algorithms, and one is object detection, and that algorithm is not publicly available. So it's not possible to make the insight in this core, but something that was important to me when I was working was the output of that algorithm, because central part of our research was not traffic sign detection, but the recognition. So the output was coordinates of this bounding box when object is detected, and that was enough for further work. Here we can see how it looks when just object detection is started on board. For recognition of traffic signs, it was used convolutional neural network. Input to this CNN was grayscale image of 28 by 28 pixels, and structure was one convolutional layer with 8 filters of size 5 by 5, followed by softmax layer. And the question is why this structure? Because this was simple enough to work on board and complex enough to solve the problem. For this CNN, I used Python and TensorFlow in a PC environment. On a PC, network was written in Python, and on board it was in C programming language. For that CNN, we need to have some data set. So I collected 7,623 images, something I recorded while someone drove me, and others are from internet. That images were split in 3 data sets. That is dataset for training, validation, and testing. These kind of pictures were collected, and then I used 2 open source tools to get this one. First tool was open labeling that I used to mark the part of the picture that I needed. And then this one is used to extract this part from whole scene. Here we can see the table that for every traffic sign, for every class, we have a number of how many picture is in which set. Something about the learning, I used Tensorboard tool to monitor the learning process, and it was used Minibatch, stochastic, gradient descent method. Here we can see the parameters. I got them with trial and error method, and here we can see the precision, graphical representation of precision and loss function during the learning process. Here we can see confusion matrix for training dataset and validation dataset. We can see that CNN got very good results because she correct good. And so when CNN was done, it was necessary to output from detection phase, prepare for recognition phase. And I already said the detection phase output of detection phase was coordinates of the bounding box. So I need to cut that part of the scene and rescale it because CNN input is 28 by 28. So I wrote two C functions. First was cut and gray, where I cut the part of the picture where is the bounding box, and I take just epsilon component from U4 to 0. And second function was rescale image function to rescale it to 28 by 28 pixels. And I just remove some pixels. Okay. Then we perform testing. We perform two forms of testing. One was testing of CNN on PC using the testing image data. And CNN got great results, and that was expected. We can see it's 97.26% precision. And we can see here the confusion matrix, and we can see that she do very well. And then we test the whole solution on ADAS board, and results wasn't very well. It was only 43.09%. And then first we thought that something with CNN was wrong, but then we look at the pictures that was input to CNN, and we can see that there is a difference between these pictures and pictures on which CNN was trained. So the results do not show satisfactory performance. The total precision is only 43.09%. And we can say that CNN is significantly affected by the accuracy of the traffic sign bounding box provided by the traffic sign detection algorithm. So traffic sign is not centered in the image, and that the image often contains an additional part of the scene, like this one. So to conclude, detection is done by an adopted algorithm. Speed limit traffic sign recognition is done by CNN. We can say that results show that CNN is capable of achieving high performance, but future work should increase the precision of the traffic sign bounding box boundaries, adding challenging images to the CNN training set itself to increase its robustness and accuracy of the CNN. And thank you for listening. That's all of me. Is there any question?
Thank you, Barbara. Thank you for your presentation and for sharing with us your impressive results. Are there some questions? Okay, while waiting for other questions, I would like to ask about that at that place you said you did cut and gray and then rescale. Why did you do the rescale for having better efficiency or for some other reasons?
Because CNN input is 28 by 28, but
Okay.
when object detection can found any size, traffic size of any size. So that was needed.
Okay, thank you. And one more question. Did you consider taking into consideration other traffic signs, not just speed limit signs? In that case, what are the differences compared to the proposed approach? Would it be completely different or very similar?
I think it's very similar. Just CNN should be trained on different data set, and everything else, I think it could be done.